Good day, my dear great turns. Today we are on the topic of the transverse wave. So, from our last video, from the introduction video, I hope you understood that transverse waves are mechanical waves. So they require medium to travel through, for example, water or air, such as sound waves. So examples of transverse wave can be ocean waves, as you can see. And imagine taking a stone and dropping it inside a pond, and the ripples that will show. Those are also examples of what transverse waves. So yes. So first and foremost, I would like you to understand that all waves come from a single pulse, meaning also including the transverse waves. They all originate from a single pulse. So what is a pulse? A pulse is a single disturbance in a medium. So the effect of a single vibration traveling through a medium is called a pulse. So the effect that happens when a vibration travels through a medium is called a pulse. For example, this is an example of a pulse. So this amplitude don't be confused by this word amplitude. It just stands for the distance between here, here, and here. So it's natural. It's nothing much, nothing special. Just the distance between. It's just the distance or the height of what the pulse. So yes, let's get into what is the transverse pulse. So the transverse pulse is a pulse in which the particles of the medium move at a right angle to the direction of motion. So yes, the transverse pulse is just particles in a medium moving at a right angle to the direction of motion. For example, let me show you this illustration. So for example, let's say there's a movement that is going to the right. Let me not say a movement. I will let me not confuse you. A direction of motion that is going to the right. Then the particles that are traveling through the medium vibrate perpendicular. So they vibrate perpendicular to the movement of motion. Hopefully that is understood. I'm not confusing you. So yes, as you can see for yourself, let me make it clear here from the diagram. As you can see for yourself, there's a transverse wave. So as this is a transverse wave, you can see that it's vibrating what? Perpendicular to what? To the direction or the motion of the pulse. So yes, hopefully that's well understood. So now we're going to enter the principle of superposition. So the principle of superposition is the algebraic. Let me highlight this. The algebraic sum of the amplitude of pulses, two pulses that occupy the same space at what? The same time. So they occupy the same space at the same time. So before we get into the principle of superposition, I would like you to understand what is a crest and what is a trough. So a crest, for example, is just when is at the top of a pulse, meaning is when a pulse goes up, and the trough is when a pulse goes down. Yes, hopefully that you can see this. So the superposition the superposition principle. So as you can see here indicated, there is a pulse going towards an oppositely directed pulse. For example, let's say this pulse has has, this pulse has four amplitudes, and also this one has four amplitudes. So they have equal amplitudes, meaning that when they collide or when they interfere, they're going to do what? They're going to add to each other. For example, meaning that is going to be what? 4 plus 4 leading to what? To an amplitude of what? Of 8. As you can see here, is doing what? A plus B. This pulse A is going towards this pulse B. This pulse B is going towards this pulse A. So when they meet at a point, they do what? They increase, they add and increase and produce a higher pulse with an increased amplitude, as you can see. So A and B, when it pulses, it produces a higher amplitude pulse. But then here's the fun part. After they have separated, they go on to regain their original amplitude and go on the same direction that they were going towards. As you can see here, pulse B was going towards what? Towards the left. And then after the interference, it is still going towards the left. Pulse A was going towards the right. And after interference, it is still going what? To the right. So yes, after interference, they regain their original amplitude and the original directions. So two interference are going to take place, which is the destructive interference and the constructive interference. So what is the constructive interference? Yes, hopefully you're asking yourself that question. So the constructive interference is the phenomenon where the crest, understand this, the crest of one pulse overlaps with the crest of another to produce a pulse of increased amplitude. So simply, it means that the crest, hopefully you can see this, the crest of another pulse overlaps with the crest of another pulse to produce an increased amplitude, meaning that this and this will add and produce a higher amplitude. For example, let's say this is 2 and here also is 2. This is going to be what? It's going to be 4. So yes, hopefully that is understood. So we're going to towards what? Destructive interference. So as you can hear, this is constructive. If you construct, what you build. Constructing is building. Then destructive is destroying. Hopefully that is clear. So destructive interference is the phenomenon where the crest, I want you to understand between crest and trough. The crest of one pulse overlaps with the trough of another, resulting in a pulse of reduced. Now we're reducing because we are what? Destructive. So we reduce since a crest and a trough meet. So as you can see, that this is what? Is a crest. This is what? Is a trough. So when these two meet, they're going to produce what? Nothing. Because, for example, they like to indicate the trough as a negative. Let's say here is -4 and here is +4. So 4 plus -4, what does it give you? It gives you 0 amplitude. So yes, this the thing is going to have what? A reduced amplitude. So yes, that is the theory of what? Superposition principle. It's a fun principle. So let's jump on to some examples of what we've been doing today. So example 1 indicate that this is example 1 and this is example 2. So example 1, a pulses move towards each other. So this pulse is what? Is positive. This one is what? Is negative. So when these pulses meet, since then they have the same, as you can see, the height is the same, has the same amplitudes, they will do what? They will destructively interfere, meaning that they will have no amplitude. Since then they what? They minus each other. After the interference, they regain to their original directions and their original amplitudes. As you can see here, that they regain to their original directions and they regain to their original what? Amplitudes. So here, this one is a different one, different theory. For example, here you can put what? 7. And here you can put what? 4. So 7 minus 4 give us what? 3. So here is going to be what? Going to be 3. It's going to be 7 minus 4. And here is going to be 2. And when they meet, they're going to minus each other. It's going to be 7 minus 4. Then there's going to be 3 left, meaning an amplitude of 3 is left. So that is why here there's a what? A little bump indicated. There's a little bump indicated. Then after that interference, both pulses will get into their original positions, original direction, and what? Amplitude. So yes, that is the theory of it. Hopefully prepare well for your upcoming exams and good luck to you.